Hi everybody, welcome back. In this video we're going to continue on our journey to start building econometrics within Python. And so we're going to start with Excel. We're going to work with the data set on CEO salaries and whether and how those are associated with the company performance. And so we're going to continue working out of the same textbook. So using Python for introductory econometrics, the abbreviation of that is upfie.net is the website. The book is there. All of the Python code is there. And so we're going to be working out of this example 2.3. And ultimately, we're going to do some simple linear regression, simple meaning only one independent variable x, and in our case, return on equity, and how it's associated with CEO salary. So we're going to build this in Excel. We're going to also do this in Python. In Python, I'll show you briefly how to do it in the very manual way, which comes from the first set of code in the chapter. And then this is going to show us what's actually happening underneath the cover of the simpler more, as they call it, black box style functions. So we'll build it in two ways, but in the end we'll be primarily using this type of underlying function within this statsmodels module. Okay, and so we're gonna start with Excel, but to do that, what we need to do is go out and get the data. And so let me just go back a little bit. Right. So if you Google Woldridge package module, you'll get a couple nice things. The Woldridge package, as I explained in one of the last videos, this module imports data automatically into Python from the internet. So it just grabs it. And so it's very convenient. And there are a whole bunch of different data sets inside of Woldridge. In fact, all of the data sets used in the textbook Introductory Econometrics by Woldridge are in this package or module called Woldridge. So modules in R, modules are called packages. And the reason I want to do that is this package is also available in R, but they have a really nice documentation of the package and all of the data sets within it. So CEO salary 1 is what we're going to be working with. You can see it's a sample of 1991 data on CEOs and salaries and their companies and so on and so forth. Here are the variables that we're going to be working with. In fact, for this video, we're only going to be working with return on equity, which is a measurement of the company's performance, and the salary of the CEO. And then it has some other information there, right, for all of the data sets. So it's really nice. Unfortunately, it's not the easiest way. It's not the easiest way to just download data and open it in Excel. So what we're going to do to get the data into Excel on that first one, which is pypy.org, and then it has the Woldridge module and project. If we go to the home page of that project, it's on GitHub. So if you want to just type that in, you could go there. But then we go to raw data, and we're going to download a CSV, comma separated values, I think. And we can see that CEO salary 1 is here. This is the data set. And I've not been able to find just a simple, download this file on this website. So if you're not familiar with how this works, you might learn a little bit of extra Excel in the process. So if we click on the raw data, we actually see the data in its CSV format. This is what a CSV file looks like. It's separated by commas, comma separated values. And if we copy all of that, so I'm going to do Control A on a Windows, Control A, Control C for copy, and bring it over here into Excel, Control V. And it still isn't nice, right? So it's all in column A. This is an easy fix. If we just select that column and go over to the Data tab here, we can do text to columns, and these are delimited by commas. So we come over here, they're delimited by commas, and we've got our data. Okay, so simple enough. You could save that off and have it for later. We're just going to go ahead and work with it. You're already in the data tab, and depending on what you've got set up on your computer, you'll have something over here that says data analysis, and that's what we're going to need. I've kind of disabled mine, so in case you don't have it, here's how you get it. It should be pre-installed on all Microsoft Excels. If we go to File and Options, go to Add-ins, and we have our Excel add-ins over here. Do the Analysis Tool Pack. This will have a whole bunch of nice tools for statistics, and that'll add this in here. So data analysis. Remember, we're going to be regressing return on equity on salary. Okay, and so these are the two columns we're going to be working with. And let's go ahead and come in here and scroll down to regression. Our Y variable is salary. Our X variable is return on equity. So I'm just hitting this and then Control Shift and then down arrow to grab it all. And we do have our labels. For now, we don't really need to worry about all these other options, but we do have the labels. 95% confidence level is fine as a default and normal. So that's all we need. Hit OK, and we're done. So we have, if we want to think of this as the regression formula, let me just copy that, paste that over here. So beta 0 is the intercept, 963. Beta 1 is the regression coefficient on return on equity, 18.50. And so we do come up with the right numbers there. We can check the standard errors to see if they're significant, also the t statistics or the p-values, and you can see that return on equity is what we would most of the time call weakly statistically significant, because it's less than 0.1. So kind of the cutoff points for statistical significance are 0.1, 0.05, and 0.01. So you'll sometimes see stars in regression output, and that's weakly significant, significant, strongly significant is the standard. If the p-value is less than these, then that's the level of significance. That's the kind of standard. So that's, hopefully you've learned about that in a statistics class. Okay, anyway, that's how we do it. Later on, we'll check more and we'll talk more about looking at R-squared values and things like that. But in Excel, if you have to do some very basic regression, it'll do you just fine. So now let's go ahead and see how we do this in Python. So I've got Spider opened up here. And like I said, what we're going to do first is we're going to do two scripts here. We're going to do the, if you're following along directly out of, the pre-made scripts, we're going to do 2.3 and 2.2. But I highly recommend that you just, or 2.3 and 2.3.2. These are the ones we're gonna work on. 2.3, remember, is we're gonna build out our regression coefficients manually. So we're gonna have to build beta 1 first, because beta 1 is used in calculating beta 0. Let's do it. And let me see if I can increase the font here. All right, so we're gonna import the Wooldridge module as woo. As okay. I'm just gonna have to type something else there. All right, and then we're gonna import NumPy as np, because and I have another video on NumPy, but remember NumPy does a lot of statistical calculations and whatnot. Because we've imported Wooldridge as the Wooldridge module, we can import our data set. So CEO sal1 is what we're going to call this data frame, woo.datawoo CEO sal1. And remember, you can put any of those data sets right here, and it's going to import that data set. Okay, let's go ahead and run that. And you can see we've got our CEO sal1. And okay, we could just use the variables as is, but for kind of basic calculations, let's call the two variables x and y. So we're going to call x, we're going to call the CEO sal1 variable return on equity. That is our x variable. Oops. And y equals CEO sal1 salary. Okay, so that's our x variable, that's our y variable, and that's confirmed, kind of right here. This is y is equal to beta 0 plus beta 1 x. Okay, now let's just follow along directly. Ingredients in the OLS formulas. All right, so we need the covariance of x and y, and that we use NumPy. So we just do the covariance of x and y, and this is a little different than what the code does, but let me just show you. So F9, 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 F9. And if we look at this covariance matrix, we have these variables here. And we only actually need second row and first column. We only need a couple of these. And so we're going to grab the second row and the first column, because this is the covariance of well, let me just double check that. Oh yeah, okay. So covariance of x and y are these, and these are equivalent. So we just need one of those to make our calculation. Okay, this is the variance of x, that's right. So this would be the variance of x, this would be the variance of y, and this would be the variance of xy, and this would be the variance of yx. And so that's why these two are the same, this is called a covariance matrix. And so we don't need the entire matrix. We only need the covariance between x and y. We don't need their individual variances. So that's why, remember, indexes start from 0. So this is the second row, first column. That's this. You could just as easily do the first row, second column. You're going to have the same number. All right, so that's fine. Okay, we've got our covariance. We need the variance of x. And the variance of x is there. But we need to specify one more parameter. And so that's going to be the degrees of freedom. And the reason we're doing that is because it's a sample, not a population. It's a sample of CEOs, not the entire population of CEOs. And let me just show you a little bit more about why we're doing that. Back to basic statistics. Population variance, population standard deviation, we're dividing by n. Sample variance and sample standard deviation, we're dividing by n minus 1. So there's that extra degree of freedom that we don't need because we've already made a calculation of the sample average. In any case, that's all that's happening here. I recommend trying it with, by default it's 0. And if you leave it as a default, or if you put 0 in here, the results aren't going to be very different, but they will be a little different, and it's an important difference. So, but in any case, this is also something that we're not going to have to do once we're working with, once we're working with the actual functionality in Python. Because we're building this manually, we're doing that. Normally, we don't have to do that. Okay, let's just do that. And so let's just look at that. The variance of x, F9, 72. Okay, and you can see that is the same number up here, 72. And that's just e to the, adding another digit there. So 72.56, 72.56. The same thing would happen if we looked at the variance of y. That's going to be that number. But we don't need the variance of y. We have the covariance of x and y. We have the variance of x. We also need to calculate beta 0. We need the mean of y and the mean of x, the sample means. So let's go ahead and do that. X bar, which is the mean, is a numpy mean of x. Run that. Y bar, numpy mean of y. Okay, and those are up there. So we have all of the ingredients, and now we just plug things in. So manual calculations of OLS. Okay, so like I said, we have to calculate beta 1 first, because beta 1 is the estimate of beta 1 is used in the estimate of beta 0. Covariance divided by the variance. We have those as variables now, so it's just easy. Divided by the variance of x. F9, beta 1, if we want to check it out, 18.5011. What did we find in Excel? 18.5011. So this is looking like I'm doing it right so far. Hopefully you are as well. Let's calculate beta 0. Y bar minus beta 1 x bar. Okay, simple enough. And y bar, minus beta 1 times x bar. Beta 0, 963.1913. And we have 963.1913. So that's that's it. We have our numbers, and 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 we've done this manually. So the last thing I want to do in this video is to actually calculate these output, but in the more standard way, the more standard approach to Python. So I want to import. We actually don't need NumPy, but I'm gonna grab these first 3 lines because we're gonna import the same data set again. So open a new script, and we don't need NumPy, but instead, whenever you're gonna be running regression, you can import this other module called statsmodels.formula.api as SMF. So, and let's close everything about what we've got here. Control L will clear the environment there, the console. And okay, so F5, that'll run the whole thing, or you could do it line by line with F9. And now we just build out an object. This is going to be we're going to assign the name regression to a regression object, smf.ols, and this will be ordinarily squares. This is the standard formula. Our formula is going to be equal to, and we put it in quotes, salary. So we put our dependent variable first, tilde, return on equity, our independent variable. And the other thing we have to do in this is call data, the data set we're using. So data is equal to CEO sal 1. If you've used R, this is fairly similar to the type of the way you'd run a regression in R. So anyway, let's run that. We have our reg, and let me just show type. Do I do type or no? I do reg.type. You don't need to do this necessarily. No, it is. Is that right? Yeah. Okay. Okay. Type reg. This is a. It's not a list. It's not a a variable. It's this thing within. It's this object within the stats model module, and there are a whole bunch of things inside of it. So, to give you some idea, we can say results is equal to reg.fit. That's also a common addition, and that's going. Oops. Whatever. Results is equal to reg.fit, and now, so from the regression object, we have this results object, which is also kind of a strange thing, and there are a lot of things inside of this results object, which we're going to be covering in all of the coming videos. But the thing that we're kind of most interested in at the moment are the parameters. So the regression parameters. So you can do it like that. And then we can look at B, and we see the intercept as before, 963.19. The coefficient of the independent variable, 18.5011. Just as all the others. And you can see, that's ultimately, you don't need that. You don't need that. With 3 lines of code, we can return everything that we did here in 20 or 15 lines of code. Okay, so yeah, this is going to be the standard way, which we'll be doing and running a lot of regressions. I'm going to be showing this, but let me just go ahead and show it now because it's going to be similar to what we see in Excel. So the output in Excel has all of this extra information. If we do results.summary, we'll get the similar output there. So regression results with all that extra information and more. And we have, the standard errors, the t-statistics, the p-values, and yeah, 213, 11, 213, 11, those all match up, right? Yeah, and so that's how you run a very, very basic regression in Excel, and how we turn that into Python code. Going forward, we're going to continue along this line of thought. We're going to be looking at a little bit more. We'll plot some of the regression output to see the scatter plot and the regression line. And yeah, we're just going to be continuing to work through this chapter 2 in the Using Python for Econometrics textbook. Thanks for watching, and I will see you in the next video.